Okay. So we have a question from the previous session yesterday. If there is no, so I can proceed. So let me share my screen. Let me quickly share my screen and okay. So can you see my screen?
Yes, sir.
All right. So yesterday we did a lot yesterday. We introduced the basics of computational chemistry, and we went further to look at the research applications areas where one can exploit if you decide to make computational chemistry your area of specialization, or maybe you are complementing it with your already specialized area. So we saw the research applications. We were able to look at the basic tools in ChemDraw for beginners. There are a lot of things here. There are a lot of things in ChemDraw, but we are taking it step at a time for beginners, introducing you to what you can easily do with ChemDraw, and there are more to it. So we look at all these tools, very important. Uh, I took it to file. In file, there were not much things in file to look at. In edit, the the important thing there in edit was the copy as, which we also looked at it. Then the view. So this view, all these things in view are what we have seen under these tools here. If you want to show analysis window, that is the analysis window. So we want to show chemical properties window. By the time we draw the structure, we'll be able to do that. So one thing you can do with ChemDraw is that you can use ChemDraw to generate chemical properties. You can use ChemDraw to generate chemical properties. So maybe if you have a structure, you can now generate the properties of that structure. But that's what you can do from this chemical, these two, this analysis window and the chemical properties window. What they all do is that they generate chemical properties, chemical descriptors of physiochemical properties of that structure. So you can easily get that from here. Then other tools too, you can get other tools. The drawing element, fragmentation tools, we have done all this part. Then under objects, there's no much thing in objects. Then in structure here, for this structure, we will not go into that for the sake of our course module. If not, you can use ChemDraw to generate NMR. Maybe I will just show you towards the end of the class by Saturday. If you can, if you would just try to remind me, I will take you to all these other parts that are not part of our module, so that you may be able to know them. Then tests is nothing much in tests. So everything you do in ChemDraw is basically on these tools here. And also, when you downloaded ChemDraw, ChemDraw also came with Chem3D. Same thing when you downloaded ChemSketch, you had a 3D viewer from ChemSketch. So when you download ChemDraw, it comes with a lot of software, but one of the most important software that it comes with is the 3D viewer, which I'll be using. So let me quickly check back our module. because that will guide me on what we are doing. Uh, Let me check back our module so we know what we have done and what we have not. What we have done and what we have not. So have you been able to download the two files I shared today?
Yes, sir.
All right, so we'll start with the first one, the practice, the one I had ChemDraw practice one, ChemDraw practice two. So I've shown you the tools used for drawing of chemical structures. Then we shall I've did some on chemical identity generation, which is our SMILE code, Eng code, and others. So now let's now draw because we did not draw structure yesterday. We just showed you the I just showed you the tools used. So we shall now see how we can use those tools today. So let me share my I'm making my screen to be into two so that it will be easier for us. So we are starting with practice one. So let's start with the first one, practice one. So we are drawing this compound, the first compound. Some of us are experts for the sake of our students, so I will just be a bit not that fast. Okay, so you can see my screen clear, right? Can you see my screen now? Very clear.
Yes, sir.
Right. So when you look at this number one structure now, you already have it, so it will be easier for you to follow up. When you look at this first structure and you want to draw it, so what we'll do is that we'll draw and we generate the name. We generate the name and the SMILE code. So when you look at this structure, it's very simple. All what you need to do is to pick up your benzene, or one can decide to draw the benzene by itself. But you pick up the benzene. When you pick up the benzene, don't bother yourself about the rotation. Uh, so when you pick up the benzene, the next thing you will do is to pick up your single bond. So there's a single bond to be attached here. There's a single bond to be attached here. I would advise you to settle all your bonds before you begin to type in atoms. So before you type in your atoms, settle all your bonds. So on that note, you have to extend the bond here and bring down another bond. Then take one up and make this one double bond. So we see how simple it is now. So it is not difficult. Then the next thing is to add your atoms now. So you go to test and capital letter, you keep your O, you come to this point, you type NH, you go to this point and you type your OH. So we have been able to draw it.
Sir, can you come back again?
Okay.
Especially in the Esther group.
Let me
I
just
mean,
come back.
in the Kabazulu group. Yeah.
Let me just come back. What we are doing is that we are drawing what is here. And the first thing to start with is your main scaffold, that is benzene. So you click benzene and you paste. So when you click benzene and paste, the next thing is your single bonds, your bond. That means you have to pick up your solid bond. So when you pick up the solid bond, then you come to this point for the one attached to OH. So once you come to that carbon, it will show blue. Once you get to that node, it will show blue, means it's right. Now, if the structure is wrong, that place where there's an error, it will show red. Like if I try to add another bond here, now what I noticing here at that place where I added the bond, can you see anything there?
Yeah, red cycle.
Red.
It's showing red circle, right?
Yeah.
Now that shows an error. Of course, it's an error because there is up to 5 bonds attached to that carbon. So this is one thing you can know if your structure is right or not. If it's wrong, then this red cycle will show around that point where there is error. So I just have to delete it, take your eraser tool and erase it. So it goes back to accuracy. All right. So the next thing you do is you still continue with your single bond, come to this position, click, it has added. Then we click again to add this one that is here, this one, add it. Then you click again from here to bring the one pointing down. So we need the one pointing up. Come to this carbon now and click, it will go up. But that place is double bond O, the carbonyl. That means you have to click on that single bond now. So once you click on a single bond, it becomes a double bond. So when you added the first bond, it was single. When you now click on the single bond, it will now become a double bond. So at this point, you have succeeded in putting your bonds. The next thing now is to include your atoms. So you go to test. So whatever you use your test to do, it will still understand if they are functional groups you are inputting. In fact, you notice that ChemDraw is very flexible and easier to use than ChemSketch. Very easy to me. It's very easy and it maintains the same bond length, because if you look at these objects, we have already keep the length is already fixed and the angles are fixed. So you won't have issues trying to drag to have a equal or unequal bond length. It just like part of the, just like the work that people did, the defense work that was done last week. Some persons their bond were longer than the other one because we use the cane sketch. But now that we are using ChemDraw, the lengths are fixed. So the bond length are fixed. So, but you can still extend the bond length if you want by unchecking this fixed length. You can uncheck the fixed length and increase the bond length. So now let me add the atoms. So I go to atoms, come to this point where you want to add that oxygen. Once you take your cursor to the terminal, it will show blue. You click on it, type your O, capital letter. Then take your cursor to this carbon, it will show blue. Click on it, type NH. Then come to this terminal, it will show blue, type OH. So on that note, you have been able to draw this structure.
But this structure is paracetamol, right?
You said?
It's paracetamol. Why do we have penalized?
Okay, let's generate the name now, so we know. Yeah, acetaminophen. So you can generate the name. Let's see, by going to structure and you say convert structure to name. You click on it, and 4-hydroxyphenyl acetamide. So that is it. Then you can generate the smile code also. You know what to do. You go to objects, you go to view, edit. You go to, so all these are chemical identities, micro, SLN, inch, and inch key. You have seen them in PubChem. If you want to get my code from PubChem, you do see all these things in PubChem. So you can also click on smiles. It has copied, you paste, then put it under. So that is the structure and the smiles. All right. So that's for number one. You can label number one. Take your test, come to this up and put number one. So that is my number one structure. I don't know why this is going down. Okay, so let us draw for let's look at the number 2 structure. So let's look at the number 2 structure. So we are just doing this, will be so fast. The essence is getting acquainted to it. So we'll be so fast. And the faster, the better. So this is still another structure. You maintain your benzene, you take the benzene, you drop the benzene, and you take your single bond. Make sure you put all your bonds. There's a single bond here, there's a bond here, there is a bond here, there is also a bond here. You come to your carbonyl now and settle your carbonyl. Then the next thing is your put your double bond. So you see, just now you are done. Then you add all your atoms. There is N2O. There is N2O. Then it's showing error. So let me come back to it. So let me say O2N, O2N. All right, so it's now correct now. So I still come back to this place. I type my oxygen. I put my OH, and this is my OH and my NO2. So you can keep doing it. It is not difficult. You generate the name, convert the structure to name, and you go to smile code. You go to your smile code, you generate the smile code, you paste, you drag it under it. So they are not difficult, is what we can easily do for ourselves. So our assignment will be given after this class on this. All right, so you can still do this. So you can still do this also. This one has charges here, plus and minus. So you can still draw it. You take your benzene. These are simple structure, at least for beginner stage. So some of you are already done with, and I just received the signal that some persons are done already. So the faster, the better. So once you are done with your bonds, you begin to add your atoms. Sorry, there should be a double bond here also. Then you start adding your atoms. There is O here. There is O here. OH. There is chlorine here. Then at this point, there is N. And there is O. So this N now, what I just need to do is to, because the N is showing me that is not correct. So let me see by adding my charge now. So let me see my positive charge. So you see that it has balanced. So the charge you are adding, ChemDraw understands your valence rule in chemistry. It understands the valence rule perfectly. Then this oxygen is showing error, but if I now put in the minus, if I take up the minus we discussed yesterday and add to the oxygen, then it will become okay. All these things are very easy and simple to draw. So we'll go to the number 4 structure. So I can skip number 4 because it's simple to draw. Then number 5. Are we together?
Yes, sir.
All right. So this is very important. You get familiarized in structural representation. So if you look at this structure too, one might be wondering, don't worry, what I will give you in assignment, you will shout Jesus. There's something that I will give you today. All of you will shout Jesus.
I
And
think
then
so.
no, it's just about five structure, but those structures, once you see it, you will shout Jesus. And then when you shout Jesus, your eye will now open. And as your eye open, you will know that you will not know why children usually cry when they come to the world for the first time. So, so just it's just small assignment for today, after today, so that you can use it to keep yourself busy tomorrow. Since we don't have class tomorrow, then why we meet on Saturday? You just keep yourself small busy tomorrow. Just five structures. But I know you will shout Jesus when you see those structures.
That's a
All
threat.
right. No, I like being sincere. I like being sincere because you must shout Jesus.
They're making us afraid.
It's better I tell you the gospel truth than to paint it like life is easier while life is difficult. So that you know what you are facing. When, when we are studying chemistry, they told us at 100 level, chemistry is so easy, so simple. What is there? Balancing chemical equation and all the rest. By the time we enter, we begin to see quantum chemistry, quantum mechanics, Schrodinger equation. Ah, but we said this is not what they told us before we are entering. So, assuming they told us chemistry is difficult, see what you face. We prepare our mind and be ready to face it. So that is where I learned my moral lesson. Okay, so now look at this thing. Now it might look.
Hello, sir.
If I say where do I want to start now?
If
Yeah.
I can ask a question, this the third structure we drew. My chlorine atom is showing red
Yes.
bulbs. Why? That chlorine atom there at the
Okay.
position.
Check if both the C and the L are capital letter. The L must be small letter.
Okay, the L on the small letter. Okay, let me check.
Chlorine now.
That's true.
How do you write chlorine?
I don't forget.
That's right. So ChemDraw understands the principles in chemistry very well.
It's fine now.
Hello, sir.
All right. Yes.
Hello. Sir, is the structure number one. Hello?
Yeah. What happened to it? Yes.
Yeah, I said in the structure number one. When you were putting NH, the N was not on top of hydrogen, but after you do it, now the N is on top of hydrogen.
It does not mean anything. It's the same thing.
Okay.
It means NH, they are not separate. It means that the N and there's a bond, there's NH bond here.
Okay.
But before, if you are typing it, it's as if after the N you see H, just like this one here.
Yes. Sir.
So they are all the same thing. The one at my right and the one at my left, they are all the same NH.
But sir, how did they able to design it in this way that NIH instead of what you have just designed?
He said, how do we do what?
I mean, this structure that you copy. Here we have NIH, but here the one you have drawn, we have N on top of hydrogen. Although they are all the same, but now the first structure that you look at and copy it, that is to design it. How did they put the NH?
Yes. In fact, no. It's just the software that generates it. In fact, I would even prefer the one we just do now. Because what we
Oh,
do now means that the H is attached to N,
okay.
because the H is attached to N. So the H must be under the N, which
Oh,
shows that the H is attached to the N. So I would even prefer this one.
oh,
Mm,
thank you.
you're welcome. So if you look at this structure now, this fifth one, because we strip the fourth structure, is simple. So if you look at this fifth structure, you start asking, where do I start from? You just have to start from somewhere. So I think I will start still from my benzene, from this benzene here. So if I take up this first benzene and I place it here, I take my single bond, I place one single bond here and another single bond here. Then I come to this end, I place a single bond. So it's very easy and friendly. If you actually look at it, it's very easy and friendly. So at this point, I will need a cyclopentane. I will need a cyclopentane to join this terminal. This terminal, I will need a cyclopentane to join that terminal. So you can pick up cyclopentane, is there. Come to this terminal, but don't see if I come to this terminal and click. Okay, it appears like this, which is still good. But most times, if you come to this terminal, you can hold your left mouse and be dragging it to maintain the position you want it to be. Right now, I am holding my left mouse. Before I click, I have not clicked yet. What I did was click on the cyclopentane, then point it to that terminal where you want it to be. Before you click, you can hold your left mouse and then begin to adjust the position to see how it will suit what you want to do. So you can also do that. You can rotate it to see how it can suit what you want to do. So whichever be the case, depending on what you encounter. Okay. So at this point now, I've added it. For now, I'm not putting the atoms yet. I'm just putting all the bonds. So that will now edit the atoms. So there is a single bond here. I pick up my single bond. There is a single bond here. There is a single bond here. So this single bond is pointing like this. Meanwhile, it's supposed to point this way. So I can keep it like this. I can decide the direction. But once I click, it's pointing. The first time I clicked, it's pointing towards my right by default. So I can make it to point towards my right, towards my left by once you come to this point, before you click, hold your left mouse, then drag it to the right, how you want it to be, then leave it. So you can actually change the position where you want the bond to be. So I've settled that of the up. I come to the down. I add this bond. The next thing is to add the benzene now that is down. I click on benzene. So I add my benzene. So I think at this point I'm done. It's now for me to add my atoms. So adding my atoms, I have here to be NH2. I have here to be NH2. NH2. Then I have here to be my O. So I put my O. Then I have here to be my N, this point. I type my N. And this is O. So the next thing is the stereo bond. So I'm done with the atoms. So the next thing to add is your stereo bonds. This is the stereo bond I told you. So you pick up this stereo bond. You come to this place. When you click, see how it's pointing. You can change how you want it depending on what you are seeing there. But I think this is the best. So then you come down also for this one. If you want to change it, you can be clicking on it. It will be changing the direction. So this is the direction from our own work. All right. So we have been able to draw the structure. So let's do the naming. Let's see the name for the structure. Oh, so you see that no matter how the structure is, ChemDraw can give you the name. That is one unique feature about ChemDraw. It can provide the name for you. And it's even the IOPAT name. So let's look at structure number 6. So I'm going to allow you to draw this and share your screen.
So that's this
So
one just that's bond facing the other side. I don't seem to. I'm trying to illustrate. It's not working.
the other side, how will I get it clear now? Which of the bond? Is it at the left or right?
Hello?
How to make it left or right?
Yes.
How to make it left or right?
I'm not
Okay.
seeing anything.
Okay. Do you mean the stable bonds, the dark bonds?
Not the dark bond. The one that has that NH2. How to make it left or right? When I click, it's showing me right. I need to make it left.
Oh, okay. I understand. Okay. See what you do. And now see what is happening to TeamSketch, to ChemDraw. If you are editing the structure, the name too will be changing. once you are changing the structure, the name will be changing. Now, see what I did now? I've removed the NH2 now. So let's say I clicked and it was like this. Okay, let me make it back. Okay, so is this the problem? Is this the problem? You want to turn it?
Yes, that's the problem, sir.
Okay, there are two ways you can do this. Uh, click your marquee, click outside, then click on that bond and turn it. So there are two ways you can do it by clicking on marquee. When you click on marquee, marquee will select the structure. I don't want to select the structure. Click outside. Once you click outside, then take your cursor to that terminal.
Yes, sir.
Once you are putting the cursor to that terminal, hold your left mouse and drag. It will follow you. It will follow you. Hold the left mouse and be dragging. So it can be playing with it. So you can do it to your satisfaction.
Okay, sir.
Have you tried it?
I just tried it. Yeah. Thank you, sir.
All right, thank you very much.
Welcome, sir.
Okay. So I would like us to draw this one and share your screen for me. So draw number 6 and share your screen. Let me see those who are following up. Draw number 6, and when you are done, you share your screen for me. Are we together? Hello, are we together?
Yes, sir.
So it won't take you 2 minutes now. So it won't take you
We
2 minutes.
we can't see your screen again.
So which yes, I've stopped sharing. So you can share your own. You have you have the folder, right? You have it with you. Or let me should I show you? Should I keep showing
Please,
you?
sir. Yes, sir. Yes, sir.
Okay, all right. Okay, sorry for that. Okay. So that is number number 6. So
Excuse me, sir.
yes, yeah, go ahead.
Yes, sir. I've not been able to generate any name for my structures. I don't know if there's any error, but it's telling me that a name could not be generated
Why?
for my structure.
Why? Select the
Okay,
structure. Even the first structure we have done,
Yes. Please, where do you go to generate that name? I forgot.
you go to like first thing is that you must select the structure. You
Yes.
must select the structure. So when you select the structure, you go to structure, go to this your menu bar. Menu bar, you see structure.
Yeah.
You click on structure. Then you come down. You see convert structure to name.
Okay. Thank you.
So once you click on that convert structure to name, the name will be generated automatically. All right. Please, ma, you said you are not able to generate your name for your structures, right?
no,
No,
I
I
Have you tried it again?
yes, I have. It's still saying a name
And
could not be
yet,
generated for this structure.
ah, what could be the problem? Would you mind sharing your screen? Let me know. Let me see what is happening there. Are you joining with your laptop?
No, I am not. I'm
Okay, you are joining with your phone.
joining my phone.
Okay, if not, I would have.
Yes, and I'm working on my
About
laptop.
okay. Is there anyone with this with similar reports like her? She said she could not generate name for her structure. Is there anyone with similar reports?
I have a similar report, but I understand why I have a problem. I
Okay,
couldn't still download what you gave us. So I just went online and I downloaded anyone. So, but from that anyone that I downloaded a ChemDraw, but not the one you gave us because I couldn't do the one you gave us. My laptop, I don't know. Anyway, so the one I downloaded can make structures, but there's nothing that place you went in structure is not on this particular it's not on this version. When you go down and you say convert structure to name or something, it's not on my own version. I'm not using the same version because I couldn't download the version you gave us. Maybe this is an older one. It doesn't have that function. But I'm able to generate the structure.
that
Please, how can I rotate? Oh, I want to rotate.
Hello, sir. Sir, I have finished. Hello.
I don't know. The network has been very bad, but you can hear me, right?
Yes.
Okay. So the please, the person with the issue of not being able to generate name, kindly use your phone to snap what you have in your system and post to the platform so I can see it and probably know what could be the problem. Then the person that complained about how to rotate, right?
Yes, sir. Yes, sir.
Yeah, can you see my screen? When you let me use this for instance. When you draw, I want to rotate propane. Okay. So if you want to rotate cyclopropane, make sure you select it. Once you select the cyclopropane, can you see this extending arrow? This extending blue line.
Yes, sir. Yes, sir.
Take your cursor to the terminal of
Okay.
that blue line.
Okay.
Once you get there, the
Okay.
cursor will turn to arrow.
Okay. Okay.
Once you take your cursor to the terminal of that extending blue line, it will turn to an arrow, like a rotating arrow.
Okay.
At that point, hold your left mouse. Hold your
Okay.
left mouse. You can
Okay.
now rotate. You can
Oh,
turn it to how you want it to be.
all right. Thank you, sir.
Yeah, you're welcome.
So did you
All
say I
right.
should upload my structure to the platform?
Yes, yes. Upload. Let me see what is the issue. Just snap it and send, so I can know. Since
It's
you can't share your
only
screen, so I can.
it's only
You
admin
say
that can send messages. It's only admin that can
no,
send
no, no. I
messages
mean,
to the group.
yeah. Are you serious? Okay. Oh, sorry for that.
Yes.
I have not. Okay, okay, okay. Let me give you permission. All right, so go ahead. Go ahead and send. So why others you can extend to number 7, you can draw number 7 for the sake while I'm attending to those who are having issues. You can draw number 7 if you are done with number 6. Number 7 is the last one, so you can. I think to some of us, this is the only time we have to practice. Anything after this lecture time is so you can try number 7 also.
I've sent it, sir.
Okay. Do you know why it's showing error? Look at it. Can you find any H2? There's a red color there now. Can you see it? Can you see the red color in NH2?
Yes, I can.
That shows is an error. So what you do is try retyping it. Like if you type NH2, so try typing, just retype it. Retype the NH2, let me see. Or you type H2N, it's still the same thing. It will appear in mirror form. Either you type NH2,
Okay, so what?
what
So
is there
what?
is N, what you type is HN2, which is wrong. You can't have HN2.
Okay, I got it. Thank you, sir.
Which one did you got? Have you noted the name?
Yeah, the name has been generated.
All right, thank you. God bless you.
Thank you, sir.
That you said we should draw number 4.
Yes, you can draw number 7.
Okay.
Yeah, that is very simple. So we are just exposing you to drawing a chemical structure. There is more to ChemDraw. So, but gradually, a step at a time. Odofin, I love your structure. It's very neat.
Thank you, sir.
Yeah. Okay. So let's look at the second practice, the second
Now
file
we
I
are,
sent.
now we are looking at that. Okay.
Yeah, look at my screen. You should have it now.
Okay.
And all of you are supposed to have it because I've already sent it to you. So you now see that it is not difficult. Drawing of structures is not difficult. So you can do this and draw in 1 hour. You can draw more than 50 structures or 100 because it's very flexible. It's not that difficult. So that was why I said you can easily draw 5,000 compound. You can easily draw 5,000 compound because it's not difficult. So you now you have seen why I said you can draw 5,000 compound, and in fact you even ask for more because you notice that the 5,000 you have drawn said is still very small. So you can even start asking for more. Okay, I believe you are done with the number 7.
No, sir. We are still at it.
Well, we should be fast. So we looked at the second file I sent. Okay. Okay. So we have done. So we shall look at after we were able to draw the second file. We should now look at 3D modeling of 3Ds. We shall look at modeling of 3Ds. So if we are able to even finish all this by tomorrow, it means we may not even need to come back on Saturday. We're able to finish what we have here. It means we'll just use Saturday for rest. But let's see how fast we can go. Okay. I've not done this chemical identity and properties. So I have to show you that. So are you done with the 7?
No, not yet, sir.
Hey, Sam, here not yet. It's very simple now. Look at it. Pick up your benzene. Once you place the benzene, you take your single bonds. So single bond. Then you pick up your 5-sided ring. The 5-sided ring, where is it?
The pentane is not oriented in the right way. That's what I'm struggling with. It's not.
You can rotate it. You can rotate it now.
I've been trying to rotate it. It's just doing another thing.
So like me, you see that I'm trying to rotate my own.
Now, how can we move down to the next page on ChemDraw? My first page is fixed up.
Okay, you press Ctrl N.
Okay, to open your page.
So the page is not continuous. Once that first page is filled up, you press Ctrl N.
Okay. Then how can I go back to the previous page?
The previous page is still there. You check that minimizing. Look at this place. This minimizing and maximizing. You can alter it. You get your first page. This minimize and restore. So you can restore the first page to come up. Or if you minimize the second page, then the first page will come up. Like, let me show you.
I finished.
All right. Thank you.
I just
Please, what does the red box mean?
Error.
I'm trying to put in my nitrogen and NH, but it's just showing red.
That means
I'm just trying to type in. I'm just trying to type in. That's all.
You showing that error means something is not balanced there. The electrons are not balanced.
Okay.
So look at it there.
It's because of the.
You said?
I share my screen to see.
So I didn't get it clear.
I said I have finished my own. I don't know whether I can share my screen to see.
Okay. That is perfect. You see, me, I just finished my own now.
So you are master.
No. I'm not master. I've shown you how to be the master. So I've already shown you. It's very flexible. ChemDraw is very flexible.
Actually, sir, it's better than the ChemSketch. During our training using ChemSketch, sir, I still can't get it right. But this one, sir, is very flexible. Once you get an error, you can easily see.
Yes.
Actually, sir, this one is actually I enjoy this one rather than the previous ChemSketch.
I think because my pentane ring is not oriented the right way. That is why it's showing error.
Okay, so try to see if you can figure that out.
And just to turn it, it's the rotation that is the problem.
But you know how to rotate it now, right?
That's what I'm trying, but it's not doing.
It's not turning.
It's not turning. I'm trying to turn it. The left, you click on it and then you use your left.
Yes, your left mouse.
Your left mouse. You said
like as you
okay.
If I click on pen, Pentine now. Before I paste it, I'll come to where I want it to appear. To show blue. Hold your left mouse now. Now begin to turn your mouse. You see that?
I've already put it. Should I remove it? I already finished drawing the structure.
Okay,
But
you've already put in the cyclopentane.
yes,
Okay, to rotate it to be a problem for
I have
you.
to
So
start all over again.
let me see if I can figure out something for you. But
I don't mind starting because it's not difficult to.
okay, you have to start.
It's not difficult to do.
Yes,
Okay.
you have to start.
Okay.
Mm. So thank God you confess is not difficult to do. Yes.
It's Dr. Henry.
Yeah, I can hear you.
Okay, it's like I'm the only person left out. I don't have any material. I don't know what you people are doing. I don't know. You promised to send it. What you sent
Hello.
is not containing any Google Drive.
I sent 2 mail to you, 2 emails.
Then
We sent two mails, 2 emails we are sent to you.
Network is
it just one. The message I was.
Hey, are you serious? Okay. All right. We are going to
Was
send it.
sent to me, there was no Google Drive inside. So for now, I've not downloaded it. Yeah,
Oh, because
I'm just moping. I'm not doing anything.
oh my God. Oh my God. That means the email did not go because we sent, but did you receive the one?
A message came, A message came.
Yes.
But in that message, there's no drive, there's no Google Drive where I can get my material.
Yes, we sent another one now that has a drive.
I didn't receive it.
Can-
And
can you-
that's still exactly with the molecular modeling. You've not still sent it.
your email is SL Okonkwo, right?
Yeah.
Yes. I carefully sent that.
Let me check back, except maybe you just sent it. But
Okay.
I was monitoring it all through today.
Let me come back to it. Let me do that right away.
Exactly.
Yeah, let me do that right away. Please, sorry that let me do that right away. So you just take me few time.
Check in your promotions folder. Sometimes it's not in the main folder. Check in your promotions folder.
I will just do that right away. Okay. So
Okay. Let me check.
yes,
Let me check.
SL Okonkwo. All right.
Yes.
At Gmail, right? You're working at Gmail.
It's a Gmail, yeah. A Gmail.
All right. All right. Kindly check now. I just sent you something.
Okay. Okay. Let me check and get back to you.
Okay. All right. So let's proceed. Why she get back to us? We are really sorry for that. So we shall then look at the second the second one. So we shall be fast. Now, please, I want us to be fast. So I will be drawing while you follow me up. Let's see how fast we can be. The faster, the better it is. So look at this. Do you think it's complex? It's still very easy to draw. Okay. Please, Esther, have you been able to see it?
No, maybe it hasn't come up. I'm on my page. I've not seen it. Maybe it might be network.
Oh,
My page is open. It hasn't come.
okay. Let's just see how it will be. If you didn't receive it, then you said for the molecular, you have not gotten the access to
Yes,
video.
you've not. Yes, no, you've not sent that one.
What about this? Okay.
From a cognitive.
You're with us on.
And that one is with that one is.
Oh, okay.
Dr. Henry, please, can you send the folder to me too?
That one I've received. That one.
The folder you sent today, can I have it too? I don't have it. I'm just following from your screen.
Okay, it's still the same drive. There was no new email. Still that same drive. That same drive that you accessed the ChemDraw.
Okay.
So that, yes, we are using that one drive.
Okay.
Okay, so Professor Excellence.
Yeah.
See what we'll do is now between us. Once, if you did not receive the mail before the training ends, I'll make sure you get it tonight. Whatever it will take me, by all means, you get it tonight. Then we would have, okay, you are with us on the macrognosis. That means we have a class tomorrow. All right. So whenever you have challenge, I will give you my personal time.
It's okay, sir.
Yes.
It's okay, sir.
Yeah, to meet up with us. I'm really sorry. I'm really, really sorry. Okay. So now let's work on this one now. So to achieve this, how do you do it? It's still very simple, but if you see, it's not a complete benzene ring. So I would just advise you take your cyclohexane, pick 3 of your cyclohexane, the cyclohexane, just pick 3, 1, 2, and 3. Then pick up your single bond, a single bond here, a double bond here, a double bond here, a double bond at this point, a double bond at this point. There is a single bond here, a single bond here. So you can direct it down. A double bond here, single bond here, and another single bond. So you see how beautiful it is. Then you add your atoms. So you pick up your atom. This is chlorine, capital C, small l. This is your nitrogen. There's a H here, and there's a H down. Then your oxygen at this point, and your OH here.
And your OH.
Then you put your stereo bond. So you change this bond to a stereo bond, and change this one to a stereo bond. Sorry.
The bonds are different. Why are they called? Why are both of them called sterol?
It's just showing you stereoisomerism. Yeah, just showing stereoisomers. Most times it's due to steric effects, electronic steric effects. Yeah.
Okay. Okay.
Are you from the chemistry background?
Well, it's part of what we have to do, but not like chemistry. I mean, there's no way you can do physiology without chemistry. But it's not deep. It's not deep.
Okay. You are of the physiology.
It's basic chemistry that we do.
Okay. Chai. It's not easy. You are really well. Let me keep quiet. Prof,
Stay on how to go back to the previous page.
Okay, now on the previous page, now you can minimize this page. If I minimize this page now, I will see the previous page. So I just minimized my own, then I came back to the previous page. Then if I want to go back to that other page, I will maximize from down. So look now, I am at this page. If I want to go back to the previous page, I will minimize. But those two pages, you have to save them differently because they have so if you are saving, you save that other one different and save this one different. So let me show you how to save. So let me come back to the first one. So maybe I want to save this one I've done here. Now that means what I'm saving is I'm saving this file. So once you click Ctrl S, once you type Ctrl S, the first option that comes out is ChemDraw. So this is ChemDraw file. So because I'm saving this whole drawing as a ChemDraw file, so you can just change the title to drawing 1 up. Yeah, just say drawing 1. So drawing 1, choose where I want to save it. Mine is going to my documents. Then choose where I want to save it. Mine is at my document. Then you say save. So at this point, you're not saving, you are saving the document as a ChemDraw file. Yes. So once you save the first one, it will not automatically save the second document. That one is a different document on its own. So I can go back to it by minimizing this one. Then I'll come to the second one and maximize the second one. Okay. Maximize this one. All right. So when I'm done with this page too, I will save it back. I will also save it. So are we together?
Yes, sir. Can you save the document in PDF file or in Word?
If you can save the document in
PDF format or
yes,
Word document?
Yes, you can save in. No, okay. Let me show you other save option. It's better I do that. Now, if you don't want to save it as ChemDraw file, you click this drop down. So on this drop down, you can save as image. You can save BMP image. You can save as image, but that means it is everything you have drawn that will be saved as image. But if you want each of them to be as image, if you want each of them to be as image file, that means you will just draw only one. You keep only one there. Maybe I want this one now. I want this one I've drawn here. I want this one to just be an image file. This one I've drawn. I will just select it. Once I select it, I will go to I will do Ctrl S. So I can make it to be an image file. I can turn it to mole file. Mole. I can use SDF. There is SDF too. So this one gives you SDF. I can save it as PNG. So here, you don't save as PDF, but ChemSketch can save as PDF. So if I choose this BMP image and I just take the name, maybe I say number 1, and I save. So I say okay. So it will save as image. So I can open it back. I can open the image number 1. So what we show is just that structure. So just that structure alone is what you see there, because that was that was the only thing that was on the page why I saved. So you see that I've saved this as image file and I've opened it, and it's showing only the structure. But when I have multiple structures and I save as image, then all the structure too will also save as image. Okay. Are we together?
Yes, sir.
All right. So you can generate the name quickly. Let's see the second structure. Let's see the second structure. So we are going to be as fast as possible. So can we do this together? I know this will be very simple for us. How do you do that? Just look at the structure and see where you can start from. I would prefer to take my cyclohexane, take another cyclohexane. Then I'll prefer to take my cyclo pentane and attach here. Then the rest becomes my single bond. So at this point, single bond, and single
Double
bond.
bond.
Then here, double bond. Then my double bond here, my double bond here. So it's very easy. My single bond here, my single bond here, my double bond here, and here my double bond,
Double bond.
my single
Single
bond,
bond. Single
uh,
bond.
my single bond, my single bond. So at this point, I put my atoms. Here is my N. Here is my O.
So the double one is in the cyclopentane.
You see?
The double one is in cyclopentane.
No. It does not matter. Both of them are sharing a double bond at that point.
Okay.
Yes, both the cyclohexane and the cyclopentane is sharing a double bond. That is what that means. So you see why this O and N is having where this error. So we'll balance it by the charge there. So I come to this place. I put my OH. This is my O. This is my H. My O. My OH. My OH, and then my stereo bonds. I have a stereo bond here. I have a wedge bond here. I have a wedge bond here. And I have a wedge bond here. So I'm done. That I put my charge, my minus charge to oxygen, and my plus charge to nitrogen. So I'm okay with that now. So let's move down to number 3. So I think I may not finish up everything. Then you can finish others by yourself, since you already have the Professor Excellence. Have you gotten anything? Oh, I can't really explain why that happened, but anyway, we'll see to it. So now, how do I do this also? You just have to start from somewhere. I will prefer starting from down. So I pick my benzene, I place my benzene. I can take my cyclo or whatever down. I tip my central bond. So okay, so I want to make it exactly the way it is now. So look at this benzene here is not having exact structure with this one. So I can rotate it. So I can just try to see how I can rotate it. All right. So I can rotate it to be exactly as it is there. Then at this point, I can pick up my cyclobentane. So take my single bond here to complete this. Then I place my double bond here, my single bond here, single bond. Then there is a single bond here. And I put another single bond. Okay, yes. And okay, so I have to turn one of them. I have to turn this to be straight. Maybe you still want to turn this to look like this, right? So I have to make this double, So then I have to take another benzene to this point like this. All right. So see, I have to rotate the benzene to fit in properly there. Then I have to pick up my single bond at this point, another single bond, another one, and the last one. So, and another single bond here. All right, so at this point, let me add my atoms. Before I do that, there's a wedge here. So I will just add that wedge. So add my atoms. There is OH here. There is NH here. And here is sulfur. And my oxygen. So it's now becoming interesting. Then here is your oxygen. And here is your oxygen. This is your OH. So the structure has been drawn. All right. So I believe we are together also, right? I can generate the name. Okay, so you can try as much as you can. Just keep trying. They are not complex. They are not difficult. Just keep trying. Keep trying to draw. Now, but I want to show something. So let's look at generating chemical descriptors and
Hello, sir. Please,
yes,
sorry. That oxygen attached to that sulfur atom. One of them is showing red box. So
in your own.
yes, sir. I don't know.
How come now? Look at it carefully. Just carefully look at it to know where the issue is coming from.
Okay, I'll look at it.
Mm. How will I figure it out for you now? All right, so let's look at
Hello, sir.
yes.
So, like, how many structures can we draw in a single document?
Can you draw area?
I said, like, how many structures can I draw in a single document?
Okay, in one
Will the,
document.
yeah, will the pages continue to increase? Like, for instance, yeah, if you want to draw more structures.
Okay, it all depends on the size. Like I can draw up to 15 here by reducing the size of my structures.
Okay.
Yes. To reduce the size, just have to select the structure. Just have to select the structure and then come towards this terminal and try to reduce it. So if you are reducing it, then it will become smaller, enabling you to add more. But even if you have exhausted this, you keep opening new document to and continue your drawing.
Okay,
Yes.
so it is not like a Word document in which when you
Oh
finish
yes,
the
yes, yes.
drawing.
It's not like word that is continuous. No, no, no.
Okay.
Yeah.
Yeah, thank you.
Okay. So you can generate chemical properties for this your structure. You can generate chemical properties for the structure. How do you generate chemical properties? You just have to let me pick any of this structure like this one. So once I've selected this one, you can come to the view. On view, you can say show analysis window. Once you click on show the analysis window, it will generate the chemical analysis showing the formula. You can see the formula C14, H14, ClNO2. And if you make any, if you alter it, as you are altering it, the values also will be changing automatically. Like if I decide to remove my OH, then it will change. If I decide to remove this bond, then it will change. So whatever you are, as you are doing, the values will be changing automatically. Now, what is the implication of this? Maybe you have an interest to design molecules whose molar mass should not be more than 500 grams. So the exact mass can now guide you. The exact mass can now guide you while you are drawing. So as you start drawing, like if my interest is I want to design compounds that the molar mass shouldn't be more than 500. So let me show you. Once I pick up my benzene, okay, let me just show you something. Maybe I want to draw this compound here. I want to draw, let me pick one. Okay, I want to draw this one, but I want to be doing it monitoring the mass so that I don't want to exceed the mass of 500. So even if I start with benzene, once I click on benzene, you know what I will do? I will go and generate the exact mass. So once I keep the analysis window, once I keep it open, then I will start doing my drawing. So anything I'm adding, it will be changing. Now, if you check the exact mass, is 78.05. So now, whatever you are adding, it will be changing. So this is enabling you to monitor. So I'm seeing my mass. So my mass is 154. It's now 154. So I continue my job. So whatever you are doing, is being is reflecting 194. So this is a clear guide that will be guiding you. So even when you are generating analogs, you have to be careful of your analog to make sure that the analogs you are generating will not be more than 500 grams. So as you do, you check 278. So it is working progressively. That is one thing I love using my ChemDraw. So I put my atoms, and you know one of the essence of all this structural software is that it enables you to model novel compounds. So you can discover novel compound and then be able to model it. So now I'm having 284. So it's, as you are drawing, is calculating for you. So drawing is calculating for you, so you know what you are doing. Now another thing we can generate apart from the chemical analysis window, you can generate the chemical properties. So while you have selected the compound, now you can paste this value. So if you click on paste, this window result, if you click on paste, then it will appear under the structure. So here we can see some of the structural data, the chemical formula, the exact mass, the molar weight, the mass to charge ratio, that is M/Z, the mass to charge ratio, then the elemental analysis. But that is not enough. You can go back to your view and choose chemical properties window. So once you click on chemical properties window, it will show you more properties. You can see boiling point, you can see the melting point, you can see the critical temperature, the critical pressure, the critical volume, the Gibbs free energy. So here you can find the Gibbs free energy, the log P for solubility, the MR, the Henry's law constant, heat of formation, TPSA, C log P, CMR. So you can say, okay, paste. You can, if you click on paste,
So
it
I'm
will
not
also
seeing your
paste.
screen.
Is anyone see my screen?
Yes, sir.
So
Okay. So once you click on paste too, it will paste under the structure. So all these are chemical descriptors. They are chemical descriptors. So if you are building your own database, let's say I want to build a database of novel compounds. So when you have modeled the structures, you will now generate these their chemical properties and include them in your database. Then you can generate the SMILE code, the inch key, the SMILE code, the inch key. You just go to your edit, as I've said, copy as, can copy the SMILE code, SLN, the inch key. So once you copy the inch key, you paste. So this one is the inch key. So this is the inch key.
So please, I can't see your screen, and I don't know how you generated the chemical properties.
Okay, can you see my screen now?
No, I don't know that
Oh,
it's just me.
that must be network then.
yeah, that is.
Okay, I can see the screen now, but please, can you show me how you got these chemical properties? Thank you,
Okay,
sir.
just select the structure. Once you select the structure, you go to view, then click on show chemical properties window. Show chemical properties window. Once you click on it, it will generate their chemical properties. But let me see whether if I change the structure, if the chemical property will also change. Let me see that. Okay, I think it will change. Yes. Yeah, it's changing. Let me see. So if I add back my NH2, I just want to play over something, NH2, and I click on it. Oh, there's a difference. So this will also help you. So once you click on paste, those chemical properties will paste under the structure. So they will paste under the structure. So this gives you information of your
Okay, thank you,
compound.
sir.
Yeah. So this gives you informations of your compound, necessary informations before you proceed to do whatever you want to do with that compound. So
But
you
sir,
can do,
these are all predictions, right?
yes, and this prediction is is, not wrong. let me show you why you can rely on this result. Let's look at benzene, just benzene itself. Let's look at benzene itself. Okay, let's just see benzene. If you want to calculate the molar mass of benzene manually, let's see if the manual molar mass calculation would be equivalent to the one that was generated. Let me use one that was predicted. So we can see to what extent can we trust this predicted result. So we are having a C6H6. So in C6H6 mean 6 carbon, 6 hydrogen. So 6 carbon is 12 times 6, 72 plus 6 hydrogen times 1, 78. So the molar mass of benzene is 78 grams per mole. So let's see the predicted value chemical analysis window. So what can you see here now on the exact mass?
Yeah, it's the function.
78.05 due to atomic mass unit. We just calculated by exact mass of 12. So
Yeah,
so now, would you like to trust the results?
definitely, sir.
It's not left for you.
So it means you now rely on this predicted values to synthesize whatever you want to synthesize before you.
Yes, you can rely on it. You can rely because the prediction is not just like you just think something and say it like the way we think and predict. It's not like the way we predict a bet Niger, our bet sporty bet or something. I don't know. Some of us.
The molar mass is not there among the chemical properties.
Okay, I generated chemical analysis window. Let me generate chemical properties. Chemical properties window. Yes, there is no molar mass in chemical property, but there is molar mass in analysis window. So there are two there. We have the analysis window and the chemical properties window. So you combine both of them. You combine both of them. So imagine now that we are using in silico tools to predict bet. All these are bet games.
So maybe you should have to generate data, like millions of data of winners and losers.
Yes. Then build a model. We'll build that model. So we will now input the new data we want to play. It will predict based on the data that it has used to train itself and tell you over 1.5 over.
But some maybe you use permutation, right?
Yes. But if you use permutation, you have to play as much sleep as possible because.
So we have seen the AlphaGo AI that one we have.
Okay.
Sorry to take you back. The weight of benzene calculated was 78, and this one is 70.05. Why the slight difference, sir?
Is atomic mass unit.
Okay, the unit.
Atomic, this thing is calculating based on their atomic mass unit, armor. Those from Igbo now, we misinterpret what I just said now, but that's by the way. So the atomic mass unit is what is being used. The exact mass.
About mass defect in our nuclear.
Yes, atomic mass defect, mass difference. So the exact mass of elements are in decimal numbers. If these mass numbers were discovered using a mass spectrometer by Aston, so they exist as isotopes. All elements exist as isotope. All. There's no element that does not exist as isotope. That was what James James Chadwick, from the experiment he conducted in 1932. So part of the experiment was repeating what Ernest Lord Rutherford did in 1911 with his boss J.J. and Marsden. So in 1932, James Chadwick repeated the same experiment, but he have to fire alpha particles on a beryllium foil instead of the gold foil. He now discovered the neutron. Now the discovery of the neutron will have to adjust Dalton's theory of 1808 that atoms of the same element are alike but differs from atoms of other elements. So from that discovery now, we notice that all elements exist as isotope. And if you remember your basic chemistry where we calculate isotopic mass, you now know that all elements, the mass numbers are always in decimal numbers. But the ones we are using now are approximated mass. We just say carbon 12, hydrogen 1, but that is not their exact mass.
That for instance, if you were to grow the isomers of this structures, can you have differences in the chemical properties?
Oh, that's a very interesting question. If you had to draw the isomers, should you have difference? Now, this computer generated information may not give account to the difference in the isomeric form because what is seen is same structure. It's seeing the same number of atoms, the same element. So it will just predict based on what it's saying there.
Okay.
Yeah.
So
Because
like if you look at like if you take this antibiotics ofloxacin and levofloxacin, one is R, one is F, and
yes,
they have different pharmacological effects against a particular bacteria, which means they may have some chemical properties differences. But in this case, you mean this software cannot give exact differences since we have the same number of
yes,
atoms, right?
yes. It may not it may not understand in situ. It may not give their difference in prop in it's been yes, that microscopic difference is as a result of difference in the structure, but this system may not do that. Just like if you are trying, let's see something. I love that question. Let me try P to lean and O to lean. So you can see, let's see what will happen. Let's see P to lean and O to lean. So this is P to lean. So for P to lean, let's see the analysis window, formula, exact mass, or probably no, let's see from chemical properties that will help us. This is P to lean, boiling point 386, melting point 194. So let me just use these two. Then okay, let me keep this aside for P to lean. Then let me draw another one for O to lean. Let me draw another one. Okay, no, okay, this is T. Let me use xylene. Sorry. This cannot give me what I want. So okay, so this is one isomer of xylene, and let me give another isomer. So let me put this one here. So this is another isomer of xylene. So let me generate chemical descriptors for this. So I really love that question. You know, uh, I can't generate two at a time. Okay, let me just generate it one by one. Then we take notes. We take note of the differences. So for this first one, let's just we are ending the class with this. This is 10 o'clock. So for the autoxylene, so this is autoxylene, and the other one at my right is metaxylene, M-xylene. So for the autoxylene, boiling point 414, melting point 218. Then let me select the metaxylene. Let me do for the metaxylene. Boiling point 414, melting point 218. So it's the same thing.
The same thing.
Yeah, it's the same thing. So that is why the system may not recognize the. But then, if you are taking these two into action, then there could be a difference in their activity because of the space, because of the spatial arrangement. So the bonding now will differ. Yeah, the bonding will differ due to the spatial arrangement. All right, we have been able to generate properties, smart code, and others you have drawn. So by our next meeting now will be on Saturday. So on Saturday, let's see. So by Saturday now, we shall take us to 3D analog and minimization. So it won't take our time. Take us to 3D analog and minimization. So just take a look of your assignments. Just have a look at your assignments. I will encourage you to take your time. Okay, no. This is not the assignments. How will I give you this? Weekend drill. I called it weekend drill. Okay. Yes. All right. Can you see my screen?
Wow.
Yes.
Oh, thank God. Nobody shouting Jesus.
One looks like honeycomb.
Good.
So does this structure exist?
They play. They ask me.
Does it exist, sir?
It exists
It's like,
that
it's like chicken.
they are super molecule now.
There's something that I noticed. Sometimes honey forms that first structure with the benzene rings, many. Honey forms that structure underwater. What does it mean? Yes. If you put water on top of honey, not the adulterated one. No. If you put water on honey and you shake it, it will form all those benzene rings under the water.
Like you used to see you see the benzene ring. I don't understand.
Yes, I see the benzene rings.
Physically or after IR spectroscopy.
That's how you know pure honey.
Wow.
The stronger the structure, some structures are scattered, so that means they have adulterated the honey. But if it is good honey, you see the structure under the water when you shake it.
Okay.
How is it physically? Or
I can't understand it.
No, she observed it, but she could not explain like the reason for that observation. But she's sharing her idea. What you
Yes, I
understand?
don't know I don't know why, but you see this structure under the
Is it
water.
is it with physical eyes or
Physical,
with question?
if you put good honey in a
Really?
plate, if you put good honey, a drop in a plate, and you put water on top and you shake
Mm.
it, you will see all those benzene rings under.
Wow.
It will
Wow.
form,
Like you
it will
don't need a
form
microscope.
no, with your eyes, it will form those hexagonal structures.
Are you serious?
I said I don't understand. I'm not saying that you see hexagonal structures, hexagonal.
Wow. Cool.
You know,
So
No,
I'm
there's
gonna
never been a science behind it.
I don't understand the science behind it. No, that's how I tell whether the
Mm.
honey is good or bad. It will
Really?
form these rings.
so let's go and buy honey and start testing. We might see it.
Exactly.
Okay,
Then,
if I'm able to check one, I will take a picture and send it to the group.
Very good, very good,
very good, man.
Oh, that's
very
It's
good.
okay.
beautiful.
We need to see benzene from honey
Actually,
in water.
Yes, sir.
Well, so
It's okay.
when I saw this structure, I just remembered that I see it underwater.
Okay,
So
so
sorry to take you back a little. How do you share your screen of ChemDraw practice questions with your with our ChemDraw practice page?
hey, I didn't get it clear.
The ChemDraw practice question you told us to download from the drive.
Uh-huh.
How did you share it side by side with your ChemDraw
Okay,
practice page?
I just
Okay.
minimize. I opened the ChemDraw practice. I opened it in the PDF. So I opened it in my Edge, from my Edge. So I would like right now. This is my Edge. So I just minimize the Edge. So you can change the dimension of the Edge. So now
So
have
mine is
minimized the edge.
overlapping.
Yes, you can figure it out. See how you can just add maybe from this edge, from the
Okay.
ending, you can
Okay.
drag
I
down.
think I've done mine. Okay.
Uh-huh.
I've
So
been battling with it since.
oh,
Like
then
I've just been quietly battling with it since.
but
As I
but
just
but
asked question now, it just moved.
wow,
I'm
that's the
like,
power of Princeton.
thank you so much, sir.
Sabat, this your terrible structure. But what would be the synthetic accessibility state?
No, it's very difficult now. It's very
This
but
one,
still,
is it like
yeah.
assignment or the project, mini project?
How will I give you this task? It's assignment you are doing today, tomorrow, to submit by Saturday. Just it's not like assignment, but try it. Because if I say assignment now, people say you don't have that time. So just try it to build your capacity. Eh? You
How
can
do
you
we
can
get
But
the
keep
assignment, sir?
okay, I'm sending it right away. I'll
Okay.
send it to the drive. So the name is Weekend Dree. Or I will send it to the WhatsApp platform.
We can drill.
How many structures? How many structures do you have here?
I have 1, 2, 3, 4, 5, 6, just six.
Okay, thank you.
It's not much.
it's not much, but looks very difficult.
No, it's tasking. If you watch, it's simple because it's the same thing that is repeating. So it's just for you to keep your brain and see how you can figure it out.
But I guess those structures are hypothetical. Do they exist in reality?
Of course, they exist.
Sir, can
But
we
they
use
are not.
our super molecule structures that is in the icon?
Don't use template, though. Don't use template. Don't use
I just thought to ask that because the template is there already.
don't use template, please. For your own good. Well, you know, smart student. So because that template you're using was done by somebody. It was drawn by somebody. So you can be that somebody now.
All
Yeah.
right.
Mm.
But I took my time today to look at each of those icons there.
That is good. Very, very perfect for that means you have done a good job.
But sir, we have to do it in more than one document, right? It's like in one document you cannot grow your structure.
In one document you can try. After drawing one, you can minimize. 6 can contain in one document. Like this thing that you're seeing here was drawn in one document before I turn it to PDF.
Is the page of that one document like A4, like in
Yes. It's like
Microsoft
A4.
Word? Okay.
Yes, you can print from there also. You can print from your ChemDraw.
Okay.
So those of us who teaches courses like organic chemistry, and you have to set questions on maybe organic structures, you can then use your ChemDraw, and you can copy the structure from there to your Word. You can copy and paste in Word documents.
Okay, just as it is like this.
No. Like in your ChemDraw, after you have finished drawing,
Okay.
like
Okay.
you can highlight this now, copy it, Control
Okay.
C, go to your Word
Okay.
document and paste.
Okay.
Yeah.
Then,
Yes.
sir, so I just want to take you back a little on
Okay.
structure. One of the structures that you made us to draw this evening,
Yeah.
the one that has N double bond oxygen and a single bond oxygen. Does the oxygen that you have there is it having a negative charge?
Is it from here? Can you see my screen? Is it the one from here?
Yeah, from the one you did today, but I'm not seeing it among these ones. That yours is numbered, my own is not numbered.
Okay, let me check. Could it be?
Yeah, and this up one, yes, this one.
Yes. So the oxygen has a negative sign. Yes.
Okay, and the nitrogen, okay, because I'm
Has
not
a
seeing
positive
it.
sign.
Okay, all
Mm.
right. Okay, I'm trying to understand why it's giving me error.
Yeah.
Oh, all right, thank you, sir.
So let me give you expo. We are preparing a training on nanotech. We use ChemDraw for that. Salusi,
Sir,
I'm giving you expo now. So battle
I
how you
should
can
be
use
ready.
ChemDraw to build a nanoparticle. We use ChemDraw to do
Wow,
that.
wow. Hey, thank you so much, sir. So when
Yeah.
are you expecting
Anytime you are ready.
it? Thank you
So I'm
so much,
giving
sir.
you expo. All right.
Thank you so much.
I really want to appreciate it. It has been a wonderful session tonight.
Yeah.
So by tomorrow, by Saturday, just get ready. What we'll be doing is now how to turn those structures, because what we are drawing is 2D, how to turn them to 3D using Chem 3D is there. Once you have installed ChemDraw, Chem 3D is there. So we'll take them to Chem 3D. Now we'll save each of them. That is where it is stressful. The drawing is not the problem, but the saving in a SDF. So you have to save each of them one by one. So imagine that you do 1,000 compound at ease. But while you are doing the saving, you start to copy them one by one to Chem 3D. When you copy, you have to optimize, then minimize energy, then save as structural data file. Then after saving as a structural data file, you save again with Notepad, so that anywhere you open the structure in Pyres, it will bear the name, no longer bearing a fragment or molecule. To now bear the name. So we shall do all that on Saturday. Then remind me, if we finish on time, to use ChemDraw to generate your spectral data. I said I will do that when I've covered my module for this training. So Saturday will be wonderful. Once again, thank you for being present. I really appreciate all your efforts and your time. Yes.
Thank you, sir.
Yeah.
So
Yeah.
fine, so
All right. Thank you.
Good night, sir.
Yeah.
Thank
Good
you
night.
very much. Good night.
Yeah.
Instructor,
Yes.
I've been able to see the folder, and
Oh, you have seen it.
yes, just it has come. I'm trying to
Glory.
open up.
Okay.
Like for the ChemDraw, I'll see when I open the folder, I saw something like a serial test. That serial stuff, is not to be clicked on now, sure?
No, you
Is
kindly
it
watch the video. There's a video on how to install ChemDraw.
okay?
Yeah. So our advice do that video is not much, just few minutes video. So
Okay.
all the necessary steps you need is there.
Okay.
So,
Thank you.
Well done, no.
So still
Okay,
remember to
have you
send
sent the assignment already?
the molecular modeling materials to me.
yes, I will do that immediately. Yeah, once. Yeah, Dr. Joseph.
Thank you.
Yeah.
Have you sent his assignment already?
Then I've not sent it. I think should I send to WhatsApp or I should add to the drive?
Please, on what?
Add it to the drive, sir.
What?
Yes, add to the drive, please.
All right. All right. All right. Just hold on. Don't. Let me just be sure I've added it. So I will tell you because once I leave.
Before you forget.
Yes. You know.
Many
things.
I think
I
you
have.
can put it in the two places.
Many classes to be attended to.
Okay. It is not easy.
It's not easy.
Okay. Have is there your drive now? Thank you.
Help
Right,
us put it in the WhatsApp too. Some people may not see it in the drive.
Okay.
Yes.
Okay. So I will put it in the WhatsApp group.
On the platform.
Please, portion.
Okay. There's no problem.
Like me
Once
now, I
again,
did not enjoy the training. Network did not allow me to enjoy. I'm
Hey,
not
Same
seeing
thing is applicable here. That's why I've been silent all this while.
the same thing. Network did not allow me to see all the drawing. I was just sharing voice.
Wow.
But I just thank God for the video that our guy is dropping. So when he drops it, I'll go and sit down by it and watch over.
Please,
Same thing the same thing I
Dr.
plan.
Harvey. Please, Dr.
Sincerely
Harvey.
speaking,
yes.
video that is
Is Windows 10 adequate for this for ChemDraw? Is Windows 10 adequate?
Yes, very much. Very much.
Because I have Windows 10 and I still had problems. So I just downloaded another version. So it doesn't have all the functions of this one you are using. I have Windows 10.
Yeah. If the problem now is for the window, I will advise you update your window.
And that's what I'm asking. Is Windows 10 not okay?
It's very, very much okay.
So it's not Windows 10. Anyway, because the version I have cannot generate structural names, but it can make structures.
Okay.
So I'm just using it like that. It's better than nothing.
Yes. But just try if it updates your Windows 10 and see if you can still carry back the ChemDraw.
Okay. Please, when is this course finishing? What I
On
can
Saturday.
get?
Saturday.
Okay. Thank you. All right. Okay. Thank you.
Okay. I think we'll call it good night.
Instructor, I'll be prioritizing you for something, okay?
There's no
Do
problem,
well
Prof.
to answer me. Thank you.
Okay. I'm trying a bit to respond to messages, so yes.
Hey, or do I tell you now? Okay, that's what I'll do. That I'll prioritize.
Yeah, just right away, Seth. I'm active now.
Okay.
Okay. So I have another class, but that will be later.
Okay. You have another class this night?
Yeah.
Jesus.
The people will not sleep.
Wow.
No, their time zone.
Or they have different time zones from us?
Yes, different time zone, yeah.
International.
But I hope you are checking your health, child.
That is why after
You
all
are
my
checking
night
your
class.
vitals.
Please, it's very necessary.
Try to rest, though.
Yeah, I do. I try. I
Very,
rest
very important.
in the morning and the afternoon. I sleep enough.
Okay.
Yes.
It is well with you, sir. God is your strength.
Thank you.
Good night, sir.
Good night.
Good night, sir.
Good night.
Bye.